Okay, welcome to another ChemSoc Mona meeting. And today we're going to make fulminating silver. And this is me, Javon Anderson, Vice President. And we have Kasha Richards. Okay, so we actually don't have any silver well, we have silver nitrate, right? So we're going to make Tollens reagent, and then we take it from there. It did not specify. Completely arbitrary. That's soluble. Well, all nitrates are silver, right? Based on my knowledge.
It's been a long time since I recall that information. Very long time.
Hot. Yeah, that's really. I think I should open the bottle. Yeah.
So it's a little too much color. Yeah, fine.
Let's hope that's silver nitrate.
It works.
Let's hope that is silver nitrate.
It's really hot. I don't know how it's so hot. And it feels like it's gonna.
It's not gonna explode, I think. It's really hot though.
Some commentary.
Okay, so we just dissolved the sodium hydroxide pellets. We're gonna we're cooling down the conical flask because it's very exothermic. And then we're gonna add it to silver nitrate in order to get the Tollens reagent.
Just a little bit.
You are?
A little bit for now. You can share it.
Okay, so this is the test of truth, guys. We don't know if it's silver nitrate, so if anything happens, I think it's too aqueous. It's too diluted. You said it should have a brown precipitate.
Sure. So,
Do you see anything brown?
no.
Wow.
Keep going. Live demonstration. What I'm gonna do, I'm gonna crack it out and see if that works. So there's,
It looks a little brownish.
no, it doesn't. I want to keep running.
It says light brown precipitate. I don't see any light brown.
Maybe silver concentration isn't strong enough.
Probably. But how will we make it strong enough? Do you think we should boil it until it's concentrated?
No, we can have a silver likes to decompose. So I'm not sure what boiling it is.
Yeah.
It's probably gonna decompose it down.
And give off like natural.
Nitric acid.
Yeah, and
We
that's.
do not want that. We do not want that in our nice recipe here.
Let's add the ammonia to see if anything will happen.
How troubling.
Okay, so
Don't wrong was asking to not reacting at all. I have no idea what's going on here, and I do not think I want to know. Put that to the side. There's one other option.
okay, so the solution that we thought was silver nitrate, it isn't.
Is it? Hold on, let me check the green. To be generous this time.
It's too diluted.
Probably it's not doing anything at all. I don't know what this is. But generally, when you get silver nitrate on your hands, your whole hand will be blushing.
Something there.
Something's there, but I don't know what that is. Generally, if it's silver nitrate on your hands, it will be gray.
All right, sorry about that, guys. The Wi-Fi and my phone was acting up. Okay, so previously we tried the nitric acid that we had with the sodium hydroxide to see if it was actually nitric acid. Well, not nitric acid, sorry. The silver nitrate, yeah. So it was actually not as concentrated as we thought. So we are gonna make silver nitrate from scratch with silver. What happened? What happened?
Um, I don't know what happened is when I don't know.
Yeah, I think it's foaming. Let me try it. But I'm not seeing any.
The signal.
Were you certain that was silver, by the way?
Yeah.
All right, so hello
Oh, we have
everyone.
Lakeisha on the block.
Um, Hi guys, I look raggedy, but that's okay. All right, so for this week's club meeting, I hope everyone is hearing me. We would be making some fulminating silver. So we would be reacting some silver nitrate with ammonium hydroxide and then adding some sodium hydroxide to the mixture. The fulminating silver is an explosive. This one, compared to the nitrogen triiodide, which is explosive when it's dry, your fulminating silver is also explosive when it is wet. So that's what we're trying to synthesize today, and we'll be looking at some alkali metal reactions such as sodium, potassium, cesium, etc. We won't be doing a demonstration for that, but we will be looking at those reactions. So we do have a shortage of silver nitrate in the lab, which is why we're attempting at this time to make some silver nitrate using silver that we have. Um, and then we would utilize that silver nitrate that we have created to react with our ammonium hydroxide and our sodium hydroxide to form silver fulminate. So while we're trying to prep that in the lab, we are going to look at the theory of explosives. Fulminating silver, we'll be looking at silver fulminate as well, which is a different explosive. Um, and we'll be looking at the alkali metals, their reaction with water. So the reaction that we will be doing from the lab itself will only be the fulminating silver, but we'll be looking at the theory for silver fulminate, fulminating silver, as well as alkali metals and water. So let's get into some theory, shall we, while we're trying to synthesize the silver nitrate. So explosive chemistry, we started the topic of explosive chemistry last week. We're just going to review what an explosive is. An explosive chemical is a solid or liquid chemical which is in itself capable by reaction of producing gas at such a temperature and pressure and at such a speed as to cause damage to the surroundings. So that makes sense, right? Explosives are substances that undergo a rapid oxidation reaction with the production of large quantities of gases, which essentially that is what makes it explode. So your explosive is reacting in such a way that at this certain temperature or pressure, it expands rapidly to produce gas. And we know that gases occupy a lot more space than solids or liquids, which is why transitioning from a solid or liquid state to the gaseous state, there's a sudden buildup of pressure. And that is where we have our explosion. And that's basically the nature of an explosion. So looking at silver fulminate, which we will not be synthesizing this compound today in the lab, your silver fulminate chemical formula AgCNO, um, and it gets its name from the fulminate ion that it has, which is a carbon triple bonded to a nitrogen, single bonded to a oxygen. That ion is called the fulminate ion, bonded to silver, which is why it's called silver fulminate. So silver fulminate is used in these things called poppets. You can find poppets, they're kind of popular in the UK. They're made up of pebbles. It has the pebbles with the explosive between it, wrapped up kind of like what they call, it's kind of wrapped up like a candy basically. So when you bite, you just hold it and you rub the two pebbles together and you have an explosion. It's not a big explosion, it's just a little pop, which is why it's called poppets. So for the poppets, it's a primary explosive, but it's not used due to its high sensitivity, which is why when you're making poppets, there is just a very small amount added to the poppets, which is why it just makes a pop sound and not a big explosion. So the properties of silver fulminate. It's a white to gray solid, and you can Google it and look at some pictures of it. It is touch sensitive, very similar to our nitrogen triiodide. It is touch sensitive and it can self detonate. So even the weight of the crystals itself can cause it to explode. It can also explode when moist, but it gives a more violent explosion when it is dry. And it also degrades in sunlight. If you add it to some thiosulfate solution, you will see it actively decomposing. All right, so the reaction of the silver fulminate is where we have our silver carbonate. So Ag2CO3 is our silver carbonate reacting with our ammonia. If we're reacting in solution, of course, our ammonia solution would be ammonium hydroxide. So it reacts our silver carbonate with our ammonium hydroxide to form our silver fulminate, which is our AgCNO. Plus water, some silver will be left over, and some oxygen. So this is in the picture that you're seeing on screen. This is basically how poppets look. That is a picture of the poppets. So they have the two pebbles in it. They put a small amount of silver fulminate between the pebbles. When you bite, you just hold it in your hand just as it's wrapped. You rub the two pebbles together and you will see a pop or hear a popping sound. So let's look at fulminating silver, which is something different from your silver fulminate. As opposed to the silver fulminate, the actual structure of this fulminating silver compound is actually unknown. The proposed mixture or complex is between silver nitride, which is Ag3N, which would be silver triple bonded to nitrogen, which is a pretty unstable structure, or silver azide, which is silver bonded to 3 separate nitrogens, right? And personally, I think the silver nitride would be the more probable structure since it has a lot more strain. Silver bonded to 3 nitrogen atoms. It would give you some strain, but it's very unusual for that kind of bonding to happen, right? So even though it's called fulminating silver, it does not contain the fulminate ion. And we just looked at what the fulminate ion was, which is carbon triple bonded to nitrogen, single bonded to oxygen. It doesn't contain that ion, right? But it's still called fulminating silver. Why? Because in old naming conventions, explosive chemicals were just referred to as fulminating. So when you would have an explosive and you observe the reaction, you would say, oh, it's a fulminating reaction or it's a fulminating element because it explodes, right? So it was just a term used to refer to explosive chemicals, which in modern day fulminates is actually referring to a compound that has the fulminate ion in it. That's the carbon triple bonded nitrogen single bonded oxygen ion, right? But it still maintains the name fulminating silver because, you know, it had that name from long time ago, so they don't bother to change it. So your fulminating silver, whereas our silver fulminate is sort of white or grayish, your fulminating silver is a black solid and it is touch sensitive. Just like your nitrogen triiodide that we did last week, and just like the silver fulminate, your fulminating silver is touch sensitive. It is not a primary explosive. So as opposed to silver fulminate, fulminating silver is not a primary explosive, but it can also explode when it's moist. And you actually find fulminating silver exploding more readily when it is moist than your silver fulminate. Why it's not used, one of the reasons it's not used as a primary explosive, well, for one, it's very sensitive when it's wet. So it's kind of hard to control, it's kind of hard to test, etc. And to store all of that, because even when it's wet, it is sensitive. So imagine when it's dry, and actually it would explode before it is completely dry. With the silver fulminate as well, silver fulminate, when it explodes, it causes more physical or mechanical damage than fulminating silver. So though fulminating silver is a bit more sensitive to touch, or it can just self-detonate, it is a bit more sensitive, but it causes less damage. So if I were to strap it onto a can, which that would be very difficult to do because it's sensitive when wet, so you definitely can't touch it when it's dry. And even when you try to transfer it when it's wet, it's really hard to get it onto anything without it exploding. But if I were to put it on, let's say, a Red Bull can and put the silver fulminate on the can as well, the silver fulminate would do a lot more damage to the can than your fulminating silver. So it would, the silver fulminate, just at that size, it would burst open the can. But the fulminating silver would probably dent it, but it probably won't burst it open. Right? Yeah. So as I said, the fulminating silver is very sensitive, so it's hard to even test it, figure out a structure or anything like that, because you would have thought this thing existed so long ago. How is it that persons don't know the structure of the compound by now? That's because it's very hard to handle. So this scientist Berthollet mentioned that dropping a few atoms of it on the ground made the black argent, and that's the old name for silver. So the black argent fulminant explode, and a water droplet was enough to set it off. So imagine you take a few atoms, and a few atoms is very small, right? If you take that, drop it on the ground, it explodes. If you drop a single droplet of water on it, it explodes. And that's dropping water on it, so it gets wet, but it still explodes. So once you prepare it, one cannot touch it or move it. It has to stay in the vessel where it is prepared, and one should not prepare more than a grain, which is known as 54 milligrams at a time, because it would just explode the container. It would just break apart the container to make it in, right? And as I said, even when it's wet, you try to move it, you're trying to test it. You can't do any of that, because even when it's wet, it's going to explode. So this is why it is, even though you don't have a structure for the compound, they don't know a lot about the compound, because they have not been able to stabilize it to where they can test it, figure out structures, do crystallography and x-rays and all of that on it, right? All right, so how do we make the fulminating silver, which is what we're trying to do today? The fulminating silver can be synthesized by decomposing your Tollens reagent, and Tollens reagent is what we use in our silver mirror test. Tollens reagent is pretty much your silver nitrate in some ammonium hydroxide. That's pretty much it. And we added, well, in the experiment, we would have added sodium hydroxide pellets. You can add it in solution, but you can just add the pellets, to be honest. But you have to add a very small amount. So you have to hold the pellets one by one to add them into the reaction. So we use our Tollens reagent and we decompose it. An accurate reaction method is not really proposed, again, due to lack of information about the product. So you don't have an accurate stoichiometric equation. You just know that if you react these things, it's going to form in solution. You don't really know what the stoichiometry is, what the mole ratio or anything like that is. You just know that if you react these things, it forms, and you can, filter it and get the product. And again, the proper structure never discovered because it's too sensitive to test. All right, let's see if we can. Okay, so for the reports on the structure elucidation, Shanley and Ennis, which are two scientists, performed valiant experiments attempting to obtain an X-ray structure of the fulminating silver and reported that many of the samples did not survive the minimum handling required to move them, container and all, to the X-ray stage. So again, even just simply trying to move the product, move the sample, even in a container in solution has been difficult to wear, because in the X-rays you will have to take it out of solution to put it on the X-ray, and once you take it out, it kind of just wants to explode just like that. We're going to see if we can get an update from Javon and Kasha in the lab to see how the synthesis of the silver nitrate is coming along. So let's do that before we hop back into some of the theory again. So next we will be looking at alkali metals and water, and how we are going to be, how those react with water, I should say. So we won't have a demonstration for that today because we're short on sodium. And we don't really have a lot of potassium in the lab. We don't have any now. Well, usually we don't have a lot because potassium is very reactive. So let's see if we can get an update on what's going on in the lab and where we are in the synthesis of the silver nitrate. Because I think that would be basically what would take a lot of time now. So once we get the silver nitrate, all we have to do is react it with our ammonium hydroxide and add our sodium hydroxide pellet to it. Javon?
Okay, thanks, Nadisha. Well, the thing is, we tried to use Kasha's. We had a piece of silver. We were trying to synthesize silver nitrate because we don't have any, but it was unsuccessful. So at this point, Okay, guys, so at this point, we're just trying to get a precipitate with the silver nitrate and the sodium hydroxide, but it's not forming, so
Yeah.
let's switch around. Okay, guys, so okay, so we didn't get any silver nitrate, so note. But thanks for being with us, and by following that theory that Nadisha provided, you can actually do the experiment and get alkali metals with water.
All right, hi guys. So I got bumped off a while ago. Not sure what the update is in the lab from Javon, but I
All right,
assume.
hi guys. So I got bumped off a while
Oops.
ago. Not sure what the
But I assume Javon would have updated you guys accordingly as to what is happening in the lab. So we're going to continue in our theory looking at our alkali metals and water. Hopefully when I get back in the lab, we can do a filming, a video of the fulminating silver, what that looks like, and post it for you guys to see. All right. So for alkali metals and water, or group one metals, um, within the periodic table, we know that they're right here, far left, the first group right there, are lithium, sodium, potassium, rubidium, cesium, francium, are collectively called alkali metals. And I believe that's a mistake, not alkali earth metals, alkali metals. Group two are called alkaline earth metals. So those are called alkali metals. So alkali metal plus water, all the alkali metals react vigorously with cold water. And if we're doing an experiment, let's say sodium and water, we usually wouldn't use some cold water because that would probably be too reactive. So we'll probably use some regular room temperature water. In each reaction, hydrogen gas is given off and a metal hydroxide is produced. So for example, with sodium, we have sodium reacting with water to form our sodium hydroxide and or hydrogen gas. It's so ironic that we have something that is so reactive, such as sodium, reacting with something so bland as good old water to form some sodium hydroxide, which It's not too dangerous, especially at, you know, pH that is closer to 7. And we have some hydrogen gas, which is flammable. So the speed and the violence of the reaction increases as you go down the group. So I don't know if you guys have ever seen something like cesium reacts. Something like cesium, it comes as a liquid. It's not solid at room temperature. It actually has a boiling point of around 28 degrees Celsius, I believe. So if you hold it in your hand, it starts to bubble. And that one is extra reactive. So potassium, of course, is more reactive than sodium, but cesium is very reactive. It looks like a gold liquid, and if you add anything in contact with it, it will just basically burst into flames. So the reactivity of the alkali metals, as I would have indicated, the reactivity increases down the group because the atoms get larger as you descend. The outer electron gets farther from the nucleus, which means your atomic radii increases. And so the attraction between your nucleus and the outer electrons gets weaker and weaker down the group because now the electron is going farther and farther away from that positive nucleus. So that internuclear attraction is very small and decreases as you go down the group, right? So it's easy for you to pull off an electron down the group. Your ionization energy is very low. So when we react our alkali metals, the electrons are easily lost and less energy is needed to form ions as we go down the group. So the subsequent hydroxides and the reactions that we observe are more vigorous when we go down the group, which is why potassium is more reactive than sodium, and cesium more reactive than both potassium and sodium. Lithium is it really does nothing when you put it in water. So it is way less reactive than sodium and potassium. And we can see that from the size of the atom, which the lithium atom is significantly smaller than even sodium. All right, so if we have not done anything today, we have went through some theory of the explosives, and we already know at the end of the meeting is question time. It's time to earn some points to see who can make it to the top of the leaderboard. So let's go into question 1. Our first question is, what is the chemical formula of fulminating silver? What is the chemical formula of fulminating silver? And of course, we already know it's the first person who gets it correct. Anyone with answers? What is the, let's see who's the correct answer. What is the chemical formula of fulminating silver? I'm seeing some answers. The correct answer is D. None of the above. So Jophine, of course, gets that right. Hi, Jophine. So the correct answer is none of the above. Remember, guys, we said fulminating silver. It's so sensitive and explosive that we can't even isolate it to get any kind of information on it. So it is fulminating silver. The answer is D, I should say. So for question 2, let's move to question 2. What color is fulminating silver? What color is fulminating silver? Is it white/gray, white, black, or none of the above? What color is fulminating silver? Let's see the answers. I'm seeing some answers coming in. The correct answer is C. And the first person to get that correct is Joffine again. All right. So let's go to question 3. Joffine is just trying to secure her semester prize. Silver fulminate and fulminating silver are not primary explosives. Is this true or false? Silver fulminate and fulminating silver are not primary explosives. Is this true or false? Let's see who's gonna get it. Let me see. Let me see the answers now. Seeing some answers coming in. And the correct answer is A. It is false. And it was a trick question because one is true and one is false. But the combined statement is false. So your silver fulminate is a primary explosive, but fulminating silver is not a primary explosive. So the statement itself is false. So Joffine got that one correct again. We're going to go to number 4. Let's see who can get this next one. Silver fulminate and fulminating silver can detonate when moist. Is that false? Is that true? Is that true or is that false? Let's see what the answers are. Seeing answers coming in now. True or false, guys? Can they detonate when moist? Persons are saying true. Is it true though? Is it? Can they detonate when moist? So the correct answer is B. Correct answer is B. I think Joffine got that first again. Yeah. Is B. They can detonate when moist, especially the fulminating silver. They can detonate when moist. All right, let's go to our next question. Guys, I can't make Joffine. I don't know what Joffine I use, but I just feel like something not something over there. So, what is the chemical formula of silver fulminate? A, B, C, or D? Is it AgN3, AgCNO, Ag3N, or none of the above? What is the answer? What is the answer? What is the chemical formula of silver fulminate? Let's see what the answers are. And the correct answer is B. Remember that we said that silver fulminate actually has the fulminate ion, which is the CNO minus. Right? So the correct answer is B. And again, Miss Joffine has gotten that correct. Hello, I don't know what Joffine is using to be this quick or just know the correct answers, or I don't know. Or maybe she's just that smart. I don't know. Let's go to the next question. Let's see who's going to get this one. Why is silver fulminate called silver fulminate? Let's see if we not get this correct. Why is silver fulminate called silver fulminate? Very simple question. Let's see what the answers are. Why is it called silver fulminate? Let's see some answers, guys. Let's see some answers. I cannot believe this. I cannot believe this. Why is silver fulminate called silver fulminate? Everybody say A. Because of old naming conventions. I would love to tell you guys that A is okay. All right. Okay. Okay. All right. So somebody redeem themselves. So Joffine redeem herself. It is C. It is because of the anion. Me literally just said that for the last question. I legit just said that when we asked what the formula was. And I said AgCNO because it actually has the fulminate ion, which is CNO. But just so that, people. So Joffine redeem herself. The answer is C because of the anion, which is the fulminate anion. CNO negative bonded to the Ag plus. That creates the silver fulminate. All right, I think we have one other question left. And this is to explain. You have to explain. Let me repeat. You have to explain. Why does silver fulminate decompose in sunlight? Why does silver fulminate decompose in sunlight? You have 10 seconds, 15, 20 seconds to tell me. So don't bother go Google anything. None of that. 15 seconds left. Nobody no want to take a guess? This is simple, you know. Why does silver fulminate decompose in sunlight? We did say it was a property that it decomposes in sunlight, but looking at the structure of the compound, why do you think it decomposes in sunlight? Easy question, people. It's very unstable and sensitive to heat. That's true, but that doesn't really explain why it decomposes. What happens? It's highly sensitive. Okay, guys, we know this. But what happens why it decomposes? In sunlight. You notice me say in sunlight because yes, it's highly sensitive, but if I have silver fulminate, if I take it out of solution, it will just blow. Just like that without even putting it in the sun. So why does it decompose in sunlight? What happens specifically in sunlight? Think about it. Sunlight. They never say if you heat it, if you hold it over a Bunsen flame, if you put it in an oven, if you put it on a hot plate. Said if we put it in sunlight. What happens? This is a big box question, now, people. You know how much points I get for this? Tell me if you give up as yet. If you have given up, I will just tell you what the answer is. And I guess you just lose 20 points.
Put on big cooking, man. Yes, dear. Oh, when I call you, you know, I just only go pushing the fan.
Guys, after 3 minutes, we have not figured it out. We haven't guessed why silver fulminate decomposes in sunlight. All right, gonna tell you the answer. The answer is because photolysis happens. So when the sunlight basically interacts with the compound, energy in the form of photons is delivered to the compound, and we know that energy is used to break bonds. So once we add energy to the compound, break the bonds, then the gaseous product is going to be formed, which means then it explodes. So the answer is really photolysis that happens, right? So the photons, the energy from the photons from the sun would cleave the bonds of the compound and allow it to explode. So I guess nobody get them points. They don't. I think Joffin took the cake to get today. I think we had, except for this bonus question, we had 6 questions, I think. And I think Joffin was the quickest in getting all of them correct. So congrats, Joffin. Guys, you know, so Joffin was the person to beat. You're not supposed to know this. Every club meeting that Joffin is the person to beat. Because Joffin is at the top of the leaderboard. And just in case you don't forget, let me just remind you guys of what the points are. Individual points, that is. Matter of fact, let me start with team points. Just to refresh your memory. We will be having a final semester activity. Everybody have exams next week. So at the end of the semester, at the end of the exam period, we will be having a final semester activity that will determine who is going to be the winner of the individual prize, as well as the team that will be on top. So right now we have actinides at 390 points, transitioners at 200 points, and lanthanides at 190 points. So actinides is way up there. Okay. At the top of the individual points table, this is not inclusive of last week's points. Was Joffin here last week? I don't remember. I think you were. But at the top, we have 90 points for Joffin at number 1. Number 2, we have Michaela with 70 points. Miguel is at number 3 with 60 points. Jazan is 40 points at number 4. Javon, 35 points. Kiana at number 6, 30 points. Mikkel at number 7, 25 points. And Brian and Stephanie tie for number 8, both at 10 points. So Joffin is at the top, almost at 100 points. Joffin gets 60 points today. I don't remember if she got points last week, but I know Michaela and Miguel were here getting points last week. So we will update you guys on the individual points. And of course, as I said, for the final event or activity or meeting for the semester, those activities will determine who will actually be the winner for the semester. All right, guys, so that's the end of today's meeting. We will update you guys on the experiment, as in we will do a video with the fulminating silver, and we will post it on Instagram and on YouTube for you guys to view that. And that's the end of today's meeting. I'll be seeing you guys next week. Remember next week, sorry. No, still the next week. Next week at exam. I'll be seeing you guys after exam. All right. And then we can see what happens and how the prices go. Please be reminded that membership fees are due. And we're going to finalize the shirt designs based on what you guys would have voted on the form. And then I'm going to get a quota for the pricing for the shirts and let you guys know. But remember, membership fees are due. Okay? And that's the end of today's meeting. Bye.